Continuing on to section 6 in our logarithms is getting you to practice the graphs on your own. And this is basically getting you to try to do this on your own. So because we know that log base 3 of x has an inverse of 3 to the x, and again I would encourage you, if you're still on the fence on how these are inverses, is because you switch x and y and then you do your boot method. So I guess I didn't switch x and y yet. Log base 3 of y equals x. Then you can do your boot method, that 3 to the x power is equal to y, is how we get to this. So again, if you're doing that 3 to the x power equals y, and you set up the problem this way, that 3 to the 0 power equals 1, 3 to the first power equals 3, 3 squared is 9, and then again negative exponents make it fractions. So -2, 1/9, 1/3, not really well done there, but 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's what the graph of 3 to the x looks like, again without crossing the x-axis. And so the premise then, let's go back to blue, is log base 3, where it would switch the x and y values around. 3, 1, 9, 2, maybe I'll even write it out. Switch x and y. And when you graph this, do not cross the y-axis. With 1/3 -1, 1/9 -2, 1/9 -2, 1, 2, 3, 4, 5, 6, 7, 8, 9. There you go. And they do want you to label your equation. So what they're talking about is rewriting, I didn't give myself enough room, log base 3 of x on that one. And then this is the graph that would be y equals 3 to the x. Okay, so the meat of this lesson, though, is talking about the domain and range. Because we can plug in anything we want in for the x values. Remember, the x's are the domains. Now, they ask for set builder notation. So if you go back to set builder notation, I'm going to switch it. I'm going to change this to interval notation. I just prefer it so much more. That I would say -∞ to infinity. Now, a different way of saying that would be that x could be any real number. But I want to see this instead. Now, the range, if we go back to the exponential function, we could only get positive answers. Even for negative exponents, we got positive answers for the y values. Now in set builder notation, that one's actually pretty easy to do, that we could write y, values for y that satisfy that y is greater than 0. So why is this the meat of the lesson? Is getting you to realize that for log functions, we can only log positive numbers. So in interval notation, we could only do from 0 to infinity, or the way we would write in set builder notation would be values for x such that x is greater than 0. And then the range would be all reals, -∞ to infinity. So let's explore that for a second. And I'm just going to a calculator, so if you need to hit pause on the video and rewatch anything, now's a good time. All I want to show you is that if I ask you to log any number, I'm just hitting the log button to keep this fast, like log of 10, that's 1. Log of 100, that's going to be 2. I can even log, and get decimals. Log of 5, log of 2. I could do log of 1. But the moment, or how about this? I can even do log of 0.1. That's fine. I can do log of 0.0001. These are all fine things. But the moment I hit log of 0, I get a domain error. Let me quit out of that. Same thing if I try to log a negative 10. I get a domain error. The point that I'm trying to make is that we can only log positive numbers. It's a very important idea, so let's write that out somewhere. I'll do it in can only log positives only. Whoops, just moved my screen over. There we go. We can only log positive numbers. So that's why when we look at this graph and they ask you to graph log base 10 of x, that you're only logging positive numbers. And it's up to you how you want to do this problem. I have some advice, but you don't have to listen to my advice. But what you could do, especially if you're struggling with this, is you could just rewrite this as 10 to the y power is equal to x. So when I go to make a table of values, it might make more sense for you to plug in like -1 for y, 0 for y, and 1 for y instead of guessing what the x value should be. Because it might be easier for you to do 10 to the 0 power is equal to 1. So the ordered pair 1, 0 would be on the curve. Same thing with plugging 1 in for y. 10 to the first power would give me 10. So if I go to my graph, 10, 1 is an ordered pair on there. I'm going to give you 1, 0 as an ordered pair. And same thing with the -1, whether you use a calculator or you just know that that's going to be 1/10 -1. But the important thing that I want you to recognize is it's not crossing the y-axis. And why is that important? Is because the domain, again, I prefer interval notation, is going from 0 to infinity, but the range is all real numbers. And I want you to be familiar with all these because you never know with multiple choice questions what kind of answers you'll see. Now this next one is a little bit trickier, just a little bit different, because this time it does cross the y-axis. And you're more than welcome to play around with your calculator. But my advice to you is to think about what needs to happen in order to shift the graph around. Because notice that this is shifted left 3 units. Why is it 3 units? So let me because it's normally it doesn't cross the y-axis. Well, this time it doesn't cross this vertical line. And if you think back to what we did a long time ago, is when we wanted to shift something to the left 3, we would add 3 inside. So before going to the calculator, I'm just telling you, you might as well cross off the few that don't really make any sense. But at the same time, that's what I'm going to do. I'm going to go to a calculator and type into y equals. Remember my shortcut, alpha window, and then the 5th option is log base. I'm just going to try the next one. I believe option 3 is the correct answer. But guess what? If it were the wrong answer, just try something else, But I'm pretty sure this is the correct answer because if I go to the graph, I can see that it has an x-intercept at -1. It crosses above the origin. And I could go to a table, second graph, and I could see, let's see, 1, 1 is an ordered pair. What's another ordered pair? -2, -1. Now the other ordered pairs are going to get errors because you can't plug in -3, otherwise you'd be logging 0. Can't plug in -4 because you'd be logging -1. So I believe that is the correct answer. And just to sort of round out our understanding, let me go back to y equals and change that log base 3. And now when I go to that graph, I think you can tell that that's not the correct x-intercept and it's not the correct answer. So feel free to guess and check. But what I really need to get out of you and get you to understand is the domain of any log. And like I said, it's a big deal. Doesn't matter what the base is, but we can only log positive numbers. And it actually doesn't matter if you have anything beyond that, like you can write plus or minus or whatever. This previous problem had a -1 on the outside, didn't matter. All that matters when I ask you for the domain of something is that what's inside the log must be greater than 0. Be ready for this phrase. Sometimes what I'll do is I'll call this piece log base b, I'll call it the argument. It's a pretty common phrase in math. So you might hear me say this: set the argument greater than 0, because it must be a positive. And at this point you can just solve it like we've solved other problems, where you add 4 to the right side and then you divide by 3 and just leave it like that. If I go back to the previous problem, I could have done this one the same way. If I set x plus 3 greater than 0 and then subtract 3 over, you could see that that's the domain. X is greater than -3. I guess one more thing I should mention before moving on is that this is sometimes called a vertical asymptote. I know we've talked about this. Not sure if that's a problem you're going to see in the homework or on a test, so it's worth writing in your notes. So the very next problem has a vertical asymptote at x equals 4/3, and the curve is to the right. One more thing before moving on is a reminder that if you ever multiply or divide by a negative, I'll just write divide by a negative, then you need to flip that inequality. So why is that important, and how does that relate to some of the other things that we've done? Is here's another problem where I really don't care what we're logging, I just care that we're logging a positive number. And at this point I would tell you to factor this. Factors of 10, 5, and 2. Well, to make it so it's -3, make it -5 and +2. And right now what I'm going to do is just set it equal to 0. I'll talk about how to get your final answer after that. So then we would have our solution set would have been 5 and -2. But if it were 5 and -2, we would have it equal to 0, and that cannot happen. So I'm going to create a number line real quick. Here's 0, here's -2, 1, 2, 3, 4, 5. I'm just going to say, well, what if you started to plug in numbers like x equals -10, or a number, I'll do x equals 0, that's an easy one to do, and then x equals maybe +10, a number that's to the right of 5. And if I start to plug that in, well, 0 would be an easy one because you get 0 minus 0 minus 10. -10, is that greater than 0? No, that is not. So we don't want the answers in there. But if you start plugging in 10 or -10, they will work, because you get 100 minus 30 is 70, minus 10 is 60, and 60 is greater than 0. And then same thing with over here. The only difference is you would get 100 plus 30, so you get 120. It's still greater than 0. So what's our final answer, or what's the domain on this? Let's see, they want an interval notation, which I prefer. Recall that we write it from -infinity to -2, parenthesis, because we do not want it to equal, and then that union symbol, because we can also plug in values to the right of 5. And maybe one more thing before cutting you loose on the homework, is to mention that you could see that on a graphing calculator. If I type into my graphing calculator, you just clear that out and log. Remember, that's implied to be a base of 10. And I just type in x squared minus 3x minus 10. And I go to my graph, you'll actually see that there's a space between -2 and 5. Why is there a space? Well, if I go to my table, we can get answers. We can get positives to the left of -2, and we can get answers positives to the right of 5. And now you're ready for the homework.